Welcome back to TechFix. This week, we're tackling one of the smartest, most safety-critical systems on the all-new Volvo VNL, the electronic braking system, or EBS. This system changes everything about how braking power is managed, monitored, and backed up. We'll look at how the EBS works, how it protects you if electronics fail, how to interpret those new warning lamps, and what every technician needs to know about diagnostics and pneumatic backup mode. Everything we're covering today comes straight from Impact. For quick reference, here's those Impact identity numbers. So let's go ahead and get into it. The electronic braking system replaces the old, purely pneumatic brake controls with an intelligent, electronically managed setup. When the driver presses the brake pedal, sensors in the digital Footbrake module measure pedal travel and pressure. That signal goes straight to the EBS control unit, which instantly calculates how much air pressure each wheel needs for stable, even braking. It then sends that command electrically to the Electro-Pneumatic Modulators, or EPMs. Each EPM takes the electronic signal and converts it into the exact air pressure needed for its brake chamber. The result? Faster, more consistent braking with stability, traction, and anti-lock control built into every press of the pedal. And here's the best part. Even if the electronics fail, the truck doesn't stop braking. It automatically switches to pneumatic backup mode using traditional air control to keep the truck safe and stopping. At the top is the EBS control unit, the brains of the operation. It interprets data from wheel speed sensors, the Footbrake module, and level sensors to balance braking power across the wheels. Oh, additionally, the steering angle sensor and yaw rate sensor are also used to determine braking pressure. On legacy trucks, the yaw rate sensor was externally mounted. Now it's integrated into the EBS control unit, thus, mounting is important. Next is the dFBM, or digital Footbrake module. This unit reads how far and how hard the driver presses the pedal. In normal EBS operation, it sends that input electronically to the control unit. But if the electronic braking system goes offline, the dFBM automatically switches to pneumatic backup mode, physically sending control air to the EPMs to apply the brakes. These electro-pneumatic actuators are the hands of the system, delivering the air pressure the control unit requests. Each EPM is preloaded from the factory with its own software and firmware, so there's no need to reprogram the component if hardware replacement is required. Front axles use single-channel EPMs. Rear axles vary depending on the configuration. Single channel on a pusher, dual channel on a drive axle for traction control. 2 dual channels if equipped with 6-channel traction control. For more information, see CBR 2533. Finally, the eTPCM, or Electronic Trailer Pressure Control Module, functions just like an EPM, but it manages the trailer's braking air. It can also enter pneumatic backup mode if communication is lost. Volvo's new air management system, or AMS, simplifies everything. The Air Production Module, or APM, now combines the air dryer and the control logic into one integrated unit. It filters moisture, oil, and debris from compressed air and manages the distribution of air through the truck's system. It draws power from the 10-amp fuse FB26 in the 12-24-volt chassis fuse box and communicates with the chassis subnet via CAN and hand control units through LIN 12. Drivers will notice the difference. No more mechanical brake knobs or complex air lines behind the dash. They'll see electronic parking brake levers, auto release when selecting a gear, and auto set when parking. This system's smarter, safer, and a lot easier to work on. Legacy systems rely on check valves to isolate failures. The APM now uses a multi-circuit protection valve, or MCPV, which acts as a distribution manifold. If a circuit starts leaking, the MCPV senses the pressure difference and closes that circuit, preserving pressure in others. When this occurs, the system will present an active DTC, which aids in troubleshooting. That means the driver can continue driving at limited capacity. It's a smarter design that prioritizes braking power above everything else, keeping the truck safe and operational while protecting air reserves. Now, here's where it all comes together. Under normal operation, the EBS controls the braking electronically. The control unit decides how much air pressure to send, keeping braking smooth and stable across all axles in all situations. But if the EBS loses a critical input, say a wheel speed sensor or pressure feedback signal, it automatically puts that axle into pneumatic backup mode. In this mode, the dFBM bypasses the control unit and sends air pressure directly to the modulators. It's mechanical braking just like legacy trucks, but without the electronics balancing the force. When this happens, the driver will see a red truck brake malfunction message if a main modulator fails and a yellow EBS warning if the trailer module is affected. During backup, brake safety features are disabled. No ABS, no stability control, no traction assist. The brake pedal feels firmer, response changes slightly, and stopping distance may increase. Here's what's happening inside. Under normal operating conditions, control air from the dFBM routes up to, but not through, a backup solenoid. The EBS control unit sends an electrical signal that opens that solenoid to allow air to the brakes. In a pneumatic backup, the solenoid opens mechanically instead, letting control air from the dFBM flow directly through to activate the brakes. That simple mechanical failsafe is what keeps the system braking even if all else fails. To make sure the pneumatic backup lines are always ready, the system performs a silent self-test to confirm the backup air paths are working correctly, not kinked, blocked, or disconnected, so backup mode stays safe and reliable whenever it's needed. This test runs automatically and more frequently in the background without affecting driver features or vehicle performance, typically during normal operation, such as key cycles and brief stopping moments. For example, right after the truck comes to a stop while the brake pedal is still applied. The test is performed one valve at a time, in sequence: front EPM, rear EPM, any additional EPMs, eTPCM, meaning the truck is not placing the entire braking system into full backup mode. It's only opening the backup solenoid for one valve at a time, recording the result, and then moving to the next valve. If a valve passes, the system stores the pass date and time for that valve. If a valve fails, the driver will receive a notification to rerun the test to reconfirm, and the system will either clear the issue or keep the warning active depending on the outcome. If the test is not run for 150 days, for example, the truck has been parked and unused, the cluster will prompt the driver to complete the test. The driver prompt is presented as a step-by-step flow of pop-ups as they progress through the process. At startup, you'll see the ABS and trailer ABS lamps illuminate for about 3 seconds. That's just the bulb check. If either lamp stays lit, there's a fault in that circuit. Hearing faint solenoid clicks from the Footbrake module during pedal press or release is totally normal. That's the system modulating and verifying response. When it's time for service, use TechTool's guided diagnostics to confirm the issue before replacing anything. Start with the temporary backup mode test. This checks that the pneumatic control is working properly. If it passes, the message "Vehicle ready to use" appears and warning lamps will clear. If it fails, you'll see red or yellow EBS warnings along with fault codes indicating which modulator or circuit needs attention. Next, run the reverse validation test. This verifies whether that failure was real or simply procedural. For example, low pressure or parking brakes still applied. If the test fails twice, take the truck out of service and investigate further. If it passes, clear the codes and recheck sensor readings. Now, let's talk about the most common issue you may see in the field. The C10129B fault indicates high or excessive flow. This comes from older APM software versions that kept counting airflow after shutdown. Here's the one-time reset procedure. First, idle the engine for 15 to 20 minutes. Then, shut the engine down, but keep the ignition on. Open, but don't start TechTool Operation 5618-07-03-02. Now, restart the engine. Let it run for 1 to 2 minutes to recharge the air system. Next, execute the operation, then confirm the DTC clears. This fix is one time only. Any future occurrence requires following standard guided diagnostics or escalation through reservice. In TechTool, the APM status test is your go-to. If you see a 928 psi pressure reading, that doesn't change, that's a failure flag. The EPM tests work the same way. If it locks to 928 psi, that modulator isn't responding. For wheel speed sensors, look for readouts around 0. A reading of negative -0.004 or similar indicates a sensor fault or wiring issue. Always verify these readings before swapping parts. Most faults are connection related, not component related. Additionally, before performing any EBS or EPB repairs, make sure the proper training is complete. That's courses 500, 990, 500, 997, and 500, 999. To recap, the electronic braking system gives you precision braking under normal conditions and safe pneumatic control when electronics fail. The new air management system and APM simplify the air circuits while improving reliability with the multi-circuit protection valve. If you see a red or yellow EBS warning, check the codes, verify air pressure, and run the backup test before replacing any parts. Remember, most issues are procedural, not hardware. EPMs come preloaded with firmware. The system self-checks every 150 days, and guided diagnostics will point you in the right direction every time. When you understand how the electronic braking system operates, both electronically and pneumatically, you'll diagnose faster, prevent unnecessary replacements, and keep every VNL safely on the road. We'll catch you next time on TechFix.
Perfect.